passing through that particular vertex, that is called the stress of a particular vertex. Similarly, we can find for V4. So what about the stress for V5? It will be 0 because no path passing through that. It is not an in-between vertex. So it will be 0. So V1 and V5 will have stress. And whereas for the other vertices, V5 and V6, so you have 6 nodes or vertices, and 1, 2, 3, 4, 5, 6, 7 edges from there. Right. Let me calculate the betweenness. Let us calculate for what we have to do. We have to find all the paths passing through that particular vertex. Let us go back to the definition. It's the X. So now I have chosen V1. So I need to find the number of shortest. The denominator, I have to take all possible shortest path. So numerator is passing through that particular vertex. So keep that in mind. So numerator is passing through that particular vertex, chosen vertex. We have chosen what is the length? 1, 2, 3. The length will be start from V2, reach V6. The other way is I can come this way. If I come this way, it will be 1, 2. That is the shortest. So the length is 2. So therefore, I have the shortest path only I need to consider. So what will be that? Shortest path is 1. Does it pass through V1? No. So therefore, it will be 0. So numerator will be 0. So V2, V6. So I finished V2 now. Similarly, I can find it for V3, 4 to V2, 1, V2 to V1, 2. Then it is 3. So we have a path of length 3 here. Other than this, we can come this way. Like this, we are going to reach V5 only now. So V4 to V3, 1, V3 to V2, V6 is 2, again 3. So we have the length of the shortest path between the node and all this closeness. So shall we quickly see for one, say for example, take this same, find closeness for V1. So what will be closeness? So this we want to get the length of the shortest path between the node and all other nodes. So that from V1 to V2, so we have 1. So V1 we are finding, right? So V1 to eigenvalue of a matrix. So that we'll get lambda by this formula. So 1 by lambda times sum. That we calculate it. So physically verifying it later tedious. So all these things we can use cytoscape to evaluate it. So this is another centrality measure. Okay. So as I said, this is what we are going to do. So we are going to use string and then we are going to use cytoscape. Let us see. So now the study which we have done, and so don't get panic with this. Yes, this is how they represent the protein. So these are all salt stress tolerant protein in sorghum bicolor. Sorghum bicolor is nothing but a millet variety. So it's a millet plant. So that experimentally, as I said, experimentally this plant was grown, and experimentally we identified that these are the 5 stress tolerant proteins. So we put into the string, and then we could get a graph with (165) protein, right? So the network which I draw was a small network. That we have a huge network. This is our network. For the network also, B5 only defined as important proteins in the network. All of them were interacting with V5 identified 5. Right. So it's already known in the literature that PPC is salt stress tolerant protein. So this 5 also interact with them, and that forms a subgraph. That all these things we could get from the analysis. Solved, but we could find they are also, so it has been extensively studied by this plant also. But we also give it a try. So far, 15 transporter, potential transporter identified early. So back among themselves. So we add 49 first shell proteins, which means that the 15, which is interacting with something else, that is the neighborhood. You just correct, which are all having neighborhood 1. So you take that 49 were there. So we identify 14. So this is the graph which we got. So 15 we know, plus we added 49 first shell interactions, which mean that we are neighbors of this 15. Download it out, and all those things you can do. So whatever you want, you can play around. I'll just put some of your friends who are doing biology. I ask them some proteins. Then you just user friendly only. It's usually easily thing. We have to download some.
If you have any queries, kindly post it in the chat box. Thank you. Thank you, sir, for giving your practical insights on protein-protein interaction protein structure, and how graph theory is important for building interaction networks. You have also highlighted participants. We will have a short break before we proceed with the second technical session. The session 2 starts around 12 noon. Thank you, sir. Al-Hadidi, Department of Computer Information Systems, Prince Abdullah bin Ghazi, Faculty of Information and Communication Technology, Al Balqa Applied University, Jordan, as our resource person. Here comes a short introduction about him. He has obtained PhD degree in Engineering Science, Computer Systems and Network from the National Technical University of Ukraine. He has 2 decades of academic experience and has published more than 40 research articles in various international journals. He had served as a keynote speaker in various international conferences. He is a member of the Scientific Research Council at Al Balqa Applied University. He has membership in various professional organizations, editorial board member and reviewer in various international journals. He is also a technical committee member in various international conferences at USA, Australia, New Zealand, Turkey, Japan, China, Canada, France, Singapore, Thailand, Romania, Italy, Portugal, and India. I welcome you, sir, to address the participants, sir.
You are, thank you for giving me this opportunity. But please, I want to know how to upload the presentation. Hello, everybody. First, I would like to thank Sri Ramaja Krishna College of Arts and Science for Women for inviting me and giving me this opportunity to participate and giving a talk in this event. International Virtual Conference in Applied Mathematics and Intelligent Computing, icamic 2021. I visited your beautiful country for speaker and chief guest for international conferences conducted in different cities. I would like also to thank the conference committees for extending their valuable time in organizing the program and all the authors, reviewers, and other contributors for their belief in the excellence of this conference. I believe that this conference will provide a good platform for students, researchers, and professors for exchange their views, knowledge, and experience. I hope this conference will be enjoyable and valuable for all of us. Thanking you. I will give you a talk, but I want to upload my presentation. Can you please, from the conference organizer, give me guide how to upload the PowerPoint slides? Can you see my screen? Can anybody see my screen?
Sir, I'm checking, sir.
Yeah, yeah. Can you see the PowerPoint slides?
No, sir.
Okay, what my first experiment in Google Meeting? How to share
Sir,
screen, please?
Yes, sir. Sir, above the
Can you-
taskbar, at the bottom of the screen, we have it called as present now, sir.
What's the name of the option?
Present now.
Code pressing now.
Yes, sir.
I cannot find this option. Present now. Okay.
Yes, sir. Yes, sir. Kindly click on that option, sir.
Yes. Yes. I have clicked. And then window.
You share your screen, sir.
Can you see it? You
Your
enter screen.
Yes, sir.
Okay.
Yes, sir.
And now share.
A window appears on the screen, sir. You have to click on that window and again give share.
Now can you see it?
Yes, sir. Yes, sir.
Yeah, can you see it? Yeah.
Yes, sir.
Okay, thank you.
Thank you, sir.
Okay. Okay, sorry for delay. This is my first conference based on Google Meeting. Okay, about very important issue of diagnosis of hardware or digital objects. The name of the presentation will be fault diagnosis of digital system using pseudorandom testing approach.
Sir,
Yeah,
kindly slideshow your screen, sir.
slideshow.
Yes, sir.
Where is it?
Sir, in the menu bar, we have slideshow, sir. Click on that, sir.
Now, okay.
So, no, sir. In the menu, can you see the slideshow, sir?
No.
Sir, kindly stop sharing now, sir. I'll tell you once again, sir.
Okay, stop sharing.
Again, you share
Okay.
it once again.
Present now.
Yes, sir. You share it once again, sir.
Okay. Present
As
now,
you've done
okay.
previously, you just present the window, sir. The entire screen.
Your enter screen, okay. Okay.
Now give share, sir. Now give share, sir.
Okay. Then. Okay. I need to upload.
Sir? Sir, kindly select the PPT, sir. You can open
Select.
now, sir.
Present now.
Sir, you went away from presenting mode, sir. Kindly click on the present now option.
Share. Okay.
Yes, sir.
Okay.
Yes, sir.
But now how to search the specific file?
So to move on tab, sir.
Which app?
So you can come out from this from this window, and you can move on to your PPT, sir, because you have shared your entire
Okay.
screen. So you can come out
Okay.
of this window, sir.
Okay. Can you see?
Yes, sir. So now press F5, sir, for slideshow.
F5.
Yes, sir.
Okay.
Okay, sir.
Okay.
Thank you, sir.
Okay. Thank you for guidance. Okay. Our talk today about pseudo-random testing approach, how to locate faults in VLSI and in different objects during the manufacturing. This model presents different techniques that are used to detect defects in digital ICs and will detect the greatest number of defects that can be present in the device with the last number of test vectors. There are three different types in general. We speaking that we have three different type of testing. The first type is exhaustive testing, could be applied every input vector. The other testing approach is functional. Using this functional testing approach, we can test every functional on the device. The third approach in the testing is fault model derived. A fine test for every model fault. Now, if we compare between these three traditional approaches, we can conclude the following. Testing which type is closest to optimum. If we have, for example, 74181 ALU chip with 14 inputs, if we use exhaustive testing, we will detect 100 of detectable faults. If we have this requires 16,038 for test vectors, a 16-bit ALU with 38 inputs would take 7.64 hours to test 10 at a speed of 10 megahertz. This is a long time. We should try to minimize that time. If we use the other approach, functional test, this will detect 100 of detectable faults. Total functions testing will take over 448 vectors. Each logical mode can be tested with about 8 vectors. Each arithmetic mode can be tested with about 20 vectors. There is no algorithmic way to verify that all functional modes have been tested. We need a designer expertise. Each traditional approach, if we use the model fault testing, if we have a single, it will detect 100% of detectable model faults, requires only 47 vectors. Vector can be generated and analyzed for fully covered using computer programs. the number of detectable actually detected by this test vector set depends on the quality of the fault model. The key is to select a fault model that can be applied to the appropriate level of circuit abstraction at the logical level, and that maps to the most possible physical defects. Now we will speak about our specific experiment, about our specific approach that called pseudorandom testing approach. It is known that the main argument in favor of its use is to simplify the intertesting procedure associated with the lack of the most labor-intensive stage of test synthesis. Recently, in connection with the successful development of methods of synthesis comparability of schemas targeted on pseudorandom testing approach. So that's called pseudorandom sequence generator, PRSG, that generate pseudorandom signals based on vector probability. This generator is known quite time ago. This is the tested block or tested object that require testing. This is the signature analyzer. We will speak later on about the signature analyzer. This component was developed firstly by HP, Hewlett Packard company. The idea is that we get a signals from the random test generator as input in the tested block, and we will have output signals from the tested block that will be analyzed by the signature analyzer. We should go get a short message that called signature. Goal should have good response. A specific signature that called a golden signature. The signature that will get from the signature analyzer will be compared with the golden one, and after that we can conclude that this component is working probably, or there is a problem or defect in the targeted tested block. Now we will speak more details about these two components. First, we will speak about PRSG, pseudorandom test generator, pseudorandom sequence generator. The main advantages or the two properties of this generator that is low cost and high operating frequency. This is the major advantages. Now we can see how does it work. For example, if we have 4-bit generator, it will be based on linear feedback shift register structure that we can see here. And this is the hardware structure, the basic hardware structure, that the last 2 bits will be run through 2 input in XOR gate. And you can see this is the loop will be repeated after 15 periods. That it is 2 to the power n minus 1. And it is the number of the bits. Here we have 4 bits to the power 15 to the power 4 minus 1. It will be 15 rounds. So here we can conclude while component to the power 4 minus 1, it will be repeated after every specific sequence will be repeated after rounds. The second property is that the probability of having ones equal of having zeros, it will be 15%. So the probability of having one or probability of having equal. What are the other known approaches of design and building pseudorandom sequence generator based on LFSRs? There are 4 different approaches or structures. The first structure will be based on linear feedback shift register. The second approach will be based on filter function generators. The third approach will be based on combinational function generator. The fourth approach will be based on clock control generator. Fifth or last approach will be based on shrinking generators. To verify the proper operation of digital devices, it is often necessary to test them with a random binary sequence. As the production of such a truly random sequence set problem, if to have available a pseudorandom sequence whose periodically is long in relation to the phenomena to be signatures will come and will be compared them, will be make some analyze to get a 4-digit signature. A short signature consists of 4 bits, and we'll compare it with the it is an effective way for troubleshooting in different systems. Okay. Here is the first model or early models for the signature analyzer developed by HP company. That this model is HP 4004. This is an early model. This is another early model of signature analyzer. Also developed by HP company. This model is HP 4006. This is pseudorandom test generator and using a typical signature analyzer. Here in our exhibit, in order to enhance the efficiency of pseudorandom testing approach. Here, I will present our proposed approach that developed by us. The aim of the work is to design a method and mean for enhancing the effectiveness of pseudorandom test procedures being applied to complicated aim will be achieved by solving the following tasks. Sharing analysis of non-structure as for organic testing for digital devices, design the parameters, control, synthesis of effective means for tested objects, output, reaction, compression, as well as design of an algorithm to detect and localize false components into digital devices. So the random testing, more or less, depending on the testing, this will help us to increase the efficiency of testing. Switching the probability of 0 and 1. The second test, the control parameter is the probability of 1 and 0 to increase or reduce the probability. The switching and to having 1 or 0. These two parameters are very critical and important because they determine the behavior of logic elements. In general, these are the maximum area of independence variation of values P, S, from switching. This is the area of this triangle. We have different analysis for getting an optimum structure of automator. Here's some mathematical analysis. Here are some structure of some input. We use C flip-flop. We will have, after mathematical analysis, the area of independent area, it will be in this line. If we use the D trigger or the D automator flip-flop, we will have the area of this parabola. We use two inputs for the generator, two independent inputs. After analysis of matrices of probability of a transition for the binary automator with two outputs, we will have the following. This is the with whole area. This is the whole area. This is the independent area that we can get. Based on this automator to this the automator, the flip-flop automator. This is an enhancement for the more probability with other programs, with other or with traditional approaches. Now, how to enhance working of signalizer. This is a traditional approach to have the output from the feedback circuit. Here is the structure. Here is the enhanced structure. The difference is to have extra input from the generator in parallel with the having the reaction from the tested object. Here is the formula of undetected errors for a traditional structure. Here is the formula for probability of undetected errors for the enhanced structure that called trustworthy signature analyzer. If we compare this formula with this formula, that we can we increase or we reduce the probability of undetected errors. This is our achievement in this experiment. Thank you once again. There are some references. Thank you for inviting me. Thank you for attention. I hope to meet you again in another conference. Thank you very much.
Participants, if you have any queries, you can post it in the chat box.
Thank you very much.
So, 1 second, sir. Participants, you can post it in the chat box. Thank you, sir, for sharing your profound knowledge with us on fault diagnosis of digital systems using pseudo-random testing approach. Thank you once again, sir, for joining with us.
Thank you very much. Thank you. Goodbye.
Thank you, sir.
Goodbye.
Instructions to the participants for presentation. I repeat, instructions to the participants for presentation. During presentation, enable your camera and unmute your mic. You have to during queries too, you have to mute your mic, and if the reviewer asks you to unmute, you can unmute. Okay, so enable your camera and unmute your mic during the presentation, and you ensure that your technical quality is good. Okay, the streaming should be good, and presentation you can do it from 4 to 6 minutes, and then you will be having a question answer session. I repeat, enable your camera and unmute your mic during the presentation, and you ensure that the technical quality of your camera is good, okay, during presentation. And the presentation can be from 4 to 6 minutes duration. So it's now 12:50. You are given 40 minutes duration for lunch break. Okay, kindly join to the lunch break. Okay, so at 12:30 you will be joining again. Sorry, by 1:30 you will be joining again. And now we will be sharing you the Google Meet of track 1 and track 2 for mathematics and track 3 for computer science. So kindly make a note of the meet link shared to you in the chat box now. so that it will help you to join later. Participants, track 1 participants should join in the same link, okay, in the link that you have joined for the conference. Track 1 participants should join in the meet link that is shared for the conference, okay. And track 2 and for track 3, track 2 for mathematics and for track 3 is for computer science. So track 2 and track 3 meet link will be shared to you in the chat box, okay, and you have to join in that link. I repeat, track 1 students, track 1 participants kindly join in this meet link, okay. And track 2 and track 3 meet link will be shared to you in the chat box for joining. Kindly make a note of it. Track 1 and track 2 is for mathematics and track 3 is for computer science. Participants, you can also check in your WhatsApp group, okay, to make a note of the meet link for tracks. Kindly check your WhatsApp group.
Good afternoon, participants. There are small changes in the organizing. So kindly listen. Track 1, track 2, and track 3. 3 separate link will be shared as well as in the chat box. After your track session, all the participants are requested to join sharply by 3 o'clock for the validatory session in the same link. Understand? So that for the track alone, a separate link is created. For track 1, separate link is there. Track 2, separate link is there. And track 3, separate link is there, which will be shared in the group as well as in the chat box. You can quit and you can join at 1:30 in the track link. After completing the track, you can join. If you have any doubts, you can just unmute yourself and ask the questions. I'll repeat once again for the newly joined members. See, 3 separate track links have created. 3 separate links will be shared in the chat box as well as in the WhatsApp group. So, join 1 and track 2 is for the mathematics. Kindly check your list, which is already shared in the WhatsApp group, and you can just join in the corresponding link. After presentation, sharp by 3 o'clock, our validatory sessions will be started. So it is mandatory to come to the validatory session to fill your feedback form to get your certificate and the proceed. And all the best paper awards will be announced only in the validatory session. Thank you.
Participants, you can quit the link. Participants, you can quit the link now and you can join in track links. At 1:30, you can join in the track links. You can quit this link now. Thank you.
Ma'am, ma'am, excuse me, ma'am. Ma'am.